Morning, dear students. With you, Mr. Hosni. Okay, and now we are gonna talk about a new lesson. It's about the wave nature of light. Okay, in the last session we had talking before about the properties of sound waves. Okay, so we will compare between the light and the sound. Okay, we will start with the definition, and let's get started. What is the sound? The sound is what we'll say it is an external factor, okay, or stimuli that affects our ears, causing what? The sense of hearing, okay? How about the definition of this light? Okay, it is the same definition, okay, except replacing the last statement of the definition of light, okay? So we will say what? I will say it is an external factor too, okay? Or stimulus that affects our eyes and causing what? Is light. So will causing the sense of what? Of vision, okay? Not the sense of hearing like the sound, okay? Now let's talk about a new important question. It is what? The sound waves are mechanical and longitudinal waves. Why mechanical? Because it needs medium to transfer through, okay? But why it is longitudinal? Because it consists of compressions and rarefaction. How about the light? Okay, the light, it is electromagnetic waves, okay? But it is transfer. Okay, it is transverse. Okay, so why it is electromagnetic? Because it doesn't need a medium to transfer through. So we can see the light of the sun, but we can hear the sound of explosion that occurs in the sun. Okay, why? Because the sound is mechanical waves and the light is what? As electromagnetic waves, so it can transfer through the vacuum. Okay, okay. This light, it is electromagnetic. In the same time, it is transverse wave. Why is transverse? Because it consists of crests and troughs. Okay, so now let's talk about the properties, okay, of this light. Before we talk about all the properties of this light, we will talk about the speed of light. Okay, is very easy. I will say it is the distance covered by what? By the light in only 1 second. So you can repeat with me again. What the mean by the speed of light? We will say it is the distance coverable by what? By the light in 1 second. Okay, and we have law to got this speed of light. Okay, and the problems. The speed of light equal distance, okay, by meter over time by second. Okay, now let's talk about the visible light. Oh, you said the visible light? So may we have invisible light? Yes, we have invisible light that we can see. Okay, well, so let's start with this visible light. The visible light, it is one of the components of electromagnetic spectrum. Okay, and the light is spectrum too. Okay, so it is one, again, I repeat again, it is one of the components of electromagnetic spectrum of the wavelengths ranges between 380 to 700 nanometer. Okay, well, so how about the gamma rays? I think you had heard before about this word. We have gamma rays and we have X-ray and we have ultraviolet. All of them, we can't see this kind of rays. Why? Because it's invisible. Okay, so we have another kind, it is infrared. This infrared, it is less than this 380 nanometer, so we can see it, okay? Like infrared and radio waves. But how about that the X-ray and the ultraviolet rays and gamma rays, all of them, they are more than the 700 nanometer. So we can see it too. So all of them, they are invisible light. Okay, that's good. How about the visible light that we can see? Okay, it starts from what? From 380 to 700 nanometer. Okay, that's good. Now let's talk about an important point, is analysis or splitting of this white light. How we do this one? We can make this analysis by what? By the prism. Okay? So, how we define this analysis of the white light? We will say it is just what? Splitting of the white light in 7 colors. They're called a spectrum colors. Okay? Well, that's good. Like what? I think you can see the compact disc. Do you know the compact disc? Okay? You can see this rainbow. Okay? These 7 colors that form the rainbow. Okay? They are the 7 colors that called the spectrum colors. Okay? Now, let's start with an activity by using the prism to analyze this white light. What we will observe by analysis this white light? If we did this, we can see this light. Okay, I'm talking about the white light. This kind of the light will analyze to the 7 colors. It starts with what? With red and orange, then yellow. So red, orange, yellow, then green, then blue, indigo, and violet. You have to memorize them by them successive. Okay, so we can make them by small word. Okay, is very good to be easy to memorize it. So we will take the first letter from each word from them. Okay, so we will start. Red will take the first letter R. Okay, orange will take O. Okay, then Y, then G, then blue, then I, and finally V. Okay, for violet. So it will be Roy, G, B, I, V. So again, Roy, Roy, G, B, I, V. Okay, so Roy, the first letter R, red. The second letter O, orange. The third one Y, yellow. Then G for green. Then blue. Okay, his first letter is B, just B. Okay, B for buck. So, and indigo is I, and finally violet starts with V. V, violet. Now we got it? Yes. Okay, that's good. Okay, let's talk about the division of these colors. This division increase while we're moving down. Okay, while we're moving down to the base of this prism. Okay, so the red will give us the lowest deviation. But how about the last one, the violet color? Well, it will give us what? The biggest or the highest deviation. Why? Because I said while we're moving down, the deviation increase. Okay? Well, because of what? Because of increasing of the frequency. So if I said the deviation increase while we're moving down till we reach to the base of the prism. Okay, so red, it has the lowest, and violet, it has what? It has the highest deviation. Why? Because of increasing of frequency. And the violet, it has the highest frequency of these colors. So we have inverse relation between this frequency and the wavelength. We have inverse relation between what? Between the frequency and the wavelength. So, and you had known that this frequency increase while we're moving down. And we have inverse relation between the frequency and the wavelength. So what will happen for the wavelength while we're moving down to? It will decrease because we have inverse relation. Okay? So when we talk about the analysis of the white light, you will say it analyzes into 7 colors. These 7 colors called spectrum colors, and it starts by its successive, okay? Starts again by red, then orange, then Y, then G, B, I, V. Can you say the name of these colors? I think you can. Now we have talking about the division of these colors too, and it starts with the red. It has the lowest division, and finally violet. It has the highest one because because of the increasing of the frequency too. So we have inverse relation between the frequency and the wavelength. So the wavelength, it has the lowest one with what? With the violet, but it has the highest one with the red. Okay, is it good? Let's carry on. Or I think we'll talk about the energy of waves, okay, in the next session, inshallah.